Our objective in this lesson is to determine the equation of a quadratic function when a table of values is given. This is actually the first part of the series, determining the equation of a quadratic function. Let's have a quick review of our previous lesson. Look at my transformations. Because of these two here, we know that this graph will be narrower by a factor of 2. Let us do that. Because of this positive 3 here, we know that our graph will move 3 units to the left. Because of negative 2 here, we know that our graph will move 2 units down. And because of this negative sign here, we know that the graph will reflect down. So here is the graph of f of x equals negative 2 times the quantity x plus 3 squared minus 2. This time, we are going to create equation from table of values. Here are the steps in creating equation from a table of values. I will go through each one of these as I discuss an example. Let's have the first one. I have here the table of values, and the first step is to make sure that this represents a quadratic function. First, we have to determine that there is an equal increment in x. 2, 4, 6, 8, 10, 12. There is an equal increment of 2. So this is check. Next, we're going to determine the first differences in y. 60 minus 42 is 18. 42 minus 27 is 15. 27 minus 15 is 12. 15 minus 6 is 9. And 6 minus 0 is 6. Now we have to make sure that the second differences in y are equal. Let us see. 18 minus 15 is 3. 15 minus 12 is 3. 12 minus 9 is 3. And 9 minus 6 is 3. Since the second differences in y are all equal, then this is check. Now we are sure that this table of values represent a quadratic function. Step 2. Select 3 ordered pairs from the table. You can choose any 3 ordered pairs. Allow me to choose the first 3 sets. So we have 2, 0, 4, 6, and 6, 15. Step 3. Substitute each ordered pair into the general form of quadratic function y is equal to ax squared plus bx plus c. Let's have the first pair, 2, 0. In this pair, we know that the first coordinate is x and the second coordinate is y. We are going to substitute 0 in our y here and 2 for our x's here. 2 squared is 4. 4 times a is 4a. So we have 0 is equal to 4a plus 2b plus c. We are going to label this as equation 1. Now let us have the next ordered pair. So again, the first one is x, the second one is y. We are going to substitute 6 for y and 4 for the x's. 4 squared is 16, and 16 times a is 16a. We simply copy 6, and then 4 times b is 4b, copy plus c. Let us label this as equation 2. The last ordered pair is 6, 15. Again, this is x and this is y. This time, our y will be 15, and the value of x is here will be 6. 6 squared is 36 times a will give us 36a. So we have 15 is equal to 36a. 6 times b is 6b. Copy plus c. This will be our equation number 3. Let us continue. So we have here our equations 1, 2, and 3. When you reach this point, your next goal is to eliminate at least one variable. And to do that, you are going to combine two equations from these three that we have here. There is no specific rule in which equations to combine, for as long as remember your goal that you have to eliminate one variable. Allow me to choose equations 1 and 2. From here, I can easily eliminate C if I am going to use the operation subtraction. Let's do it. 0 minus 6 is negative 6. 4a minus 16a is negative 12a. 2b minus 4b is negative 2b. And then c minus c will simply cancel out. I was able to eliminate the variable c. I will name this as my equation 4. I am going to choose another two equations. Let me choose equations 2 and 3. So from here, since I eliminated c here, I will also eliminate c in these equations. So to do that, I'm going to use again the operation subtraction. So 6 minus 15 is negative 9. 16a minus 36a is negative 20a. 4b minus 6b is negative 2b, and then c minus c will simply cancel out. This is now my equation number 5. Notice that in both equations, 4 and 5, I do not have the variable c. So the next step is to combine these equations. Let me rewrite them. This time, we are going to choose another variable to eliminate, a or b. Since the coefficients of my b are the same, then I can easily eliminate b by choosing again subtraction as my operation. Negative 6 minus negative 9 will become negative 6 plus 9, and that is equal to 3. Negative 12a minus negative 20a is equal to 8a, and negative 2b minus negative 2b, this will become plus, so negative 2b plus 2b will simply cancel out. Since I only have one variable now, I can easily solve for the value of it. I'm going to divide both sides by 8. So 8 and 8 here will cancel out. So a is equal to 3 over 8. This is now my equation 6. Since I already have the value for a, I can substitute this to either equation 4 or 5. Let me choose equation 4. So I'm going to substitute equation 6 to equation 4. Meaning, I am going to substitute a, which is 3 over 8, in here. 12 and 8 can be simplified. They are both divisible by 4. 12 divided by 4 is 3, and 8 divided by 4 is 2. Now I have 3 times 3, that is equal to 9. So this portion will be negative 9 over 2. I am going to eliminate first this denominator. To do that, I am going to multiply both sides by 2. 2 times negative 6 is negative 12. And then distributing 2, 2 and 2 here will cancel out. So I have negative 9. And then 2 times negative 2b is negative 4b. To solve for b, I will move this negative 9 on the other side. Negative 12 plus 9 is negative 3. Then I will divide both sides by negative 4. Negative 4 here will simply cancel out. So b is equal to negative over negative is positive. B is equal to 3 over 4. This is now my equation number 7. Let us continue. So I have here equations 1, 2, 3, 4, 5, 6, and 7. Since I already know the values of a and b, I can substitute equations 6 and 7 to any of the first three equations. It seems that equation 1 is easy to work with, so I will choose equation 1. Let me substitute the value of a, which is 3 over 8, in here, and the value of b, which is 3 over 4, in here. 4 and 8 can be simplified. This is 2. 2 and 4 can be simplified as well. 4 divided by 2 is 2. So this will become 3 over 2 plus 3 over 2 plus c. Same denominator, we simply add the numerators. 3 plus 3 is equal to 6. Copy the denominator. So this is 6 over 2, copy plus c. And 6 divided by 2 is equal to 3. To solve for c, I'm going to move 3 on the other side. So I have c is equal to negative 3. Now my variables are complete. I have a, b, and c. Let us recall the general form of quadratic function. Let us substitute now the values of a, which is 3 over 8, b, which is 3 over 4, and c, which is negative 3. Here is now our quadratic function. Now, are you interested on the parabola of this equation? Here it is. So here are the 3 points that we chose earlier: 2, 0, 4, 6, and 6, 15. Let us have another example. Again, step 1 is we have to make sure that this table represents a quadratic function. So first test, there should be equal increment in x. Negative 3, negative 2, negative 1, 0, 1, 2, 3. There is an equal increment of 1. So this is check. Next one, we're going to get the first differences in y. Negative 1 minus negative 3 is 2. Negative 3 minus negative 3 is 0. Negative 3 minus negative 1 is negative 2. Negative 1 minus 3 is negative 4. 3 minus 9 is negative 6. 9 minus 17 is negative 8. Now we have to make sure that the second differences in y are equal. 2 minus 0 is 2. 0 minus negative 2 is 2. Negative 2 minus negative 4 is 2. Negative 4 minus negative 6 is 2. Negative 6 minus negative 8 is 2. Since the second differences in y are all equal, then we are sure that this table represents a quadratic function. Step 2, we are going to select three ordered pairs from the table. We can choose any three ordered pairs. Let me choose this one, another one, and this one. So those are negative 1, 3, 1, negative 3, and 3, negative 1. Step 3, we're going to substitute each ordered pair into the general form of a quadratic function. So let us start with the first ordered pair, negative 1, 3. Again, the first one is x, the second one is y. So the value of y here is 3, and the value of x's here is negative 1. Negative 1 squared is 1 times a is still a. Negative 1 times b is negative b. And then we simply copy 3 and c. This is our equation 1. Let's proceed with the second ordered pair. Again, this is x and this is y. So our y this time is negative 3. And the value of x is here is positive 1. 1 squared is 1 times a is still a, and 1 times b is b. Copy negative 3 and c here. This will be our equation 2. And the last ordered pair, we have 3, negative 1, x, y. Our y this time is negative 1, and the x's here will be positive 3. 3 squared is 9, and 9 times a is 9a. 3 times b is 3b. Copy negative 1 and c. This will be our equation 3. Let us continue. Here are our equations 1, 2, and 3. From this point, our goal is to eliminate at least one variable. You can choose any two equations here. Let me choose equations 1 and 2. So I will analyze which variable can I easily eliminate. I can eliminate B, they have the same numerical coefficients. I can also eliminate C, they have the same numerical coefficients. This will depend on the operation that I am going to use. In my first example, I use subtraction. This time, I'm going to use addition. 3 plus negative 3 will be 0. A plus A is 2A. Negative B plus positive B will simply cancel out. And C plus C is equal to 2C. This is my equation 4. I will choose again two equations. This time, let me choose 1 and 3. Since I eliminated variable b in equation 4, I am also going to eliminate variable b in these equations. How am I going to do it? The numerical coefficient of b here is the invisible one, while in here is 3. To eliminate b, they should have the same numerical coefficient. So what I am going to do is to multiply both sides of equation 1 by 3. 3 times 3 will give me 9. And then 3 times A is 3A. 3 times negative B is negative 3B. 3 times C is positive 3C. Let me rewrite equation 3. Now that the coefficients of my B are equal, I can easily eliminate them. How? I am going to choose the operation addition. 9 plus negative 1 will give me 8. 3A plus 9A is 12A. Negative 3B plus positive 3B will simply cancel out. 3C plus 1C is equal to 4C. This is now equation 5. I'm going to combine now equations 4 and 5. They both do not have the variable b. Let me rewrite them. Again, we are going to choose one variable to eliminate. Which one is easier to eliminate? I think that would be variable c. I simply have to multiply equation 4 by 2. Let's do it. 2 times 0 is 0. 2 times 2a is 4a, and 2 times 2c is 4c. Let me rewrite equation 5. Notice now that the coefficients of c in the two equations are equal. So I can eliminate variable c by choosing subtraction. Let's do it. 0 minus 8 is negative 8. 4a minus 12a is negative 8a. And 4c minus 4c will simply cancel out. Now, I only have letter A, and I can easily solve this by dividing both sides by negative 8. So negative 8 and negative 8 will cancel out. Negative 8 divided by negative 8 is equal to 1. So 1 is equal to A, or A is equal to 1. This is equation 6. Now I can substitute equation 6 either to equation 4 or equation 5. It seems to me that equation 4 is much easier to manipulate. So I'm going to substitute equation 6 to equation 4. Meaning I am going to substitute the value of A, which is 1, in here. So 2 times 1 is 2. To solve for C, I am going to move this 2 on this side. It will become negative 2. And to solve for C here, let us divide both sides by 2. So 2 and 2 will cancel out. Negative 2 divided by 2 is negative 1. So negative 1 is equal to C, or C is equal to negative 1. This is equation 7. Let's continue. So we have here our equations 1 to 7. Since I already know the values of A and C, I can substitute equations 6 and 7 to any of the first three equations. Let me choose equation 1. This looks the simplest equation among the three. So let us substitute 6 and 7 to equation 1, meaning I'm going to substitute 1 for A and negative 1 for C. Positive negative will become negative 1. And 1 minus 1 will simply cancel out. So this means 3 is equal to negative B. Or by dividing both sides by negative 1, this will give me B is equal to negative 3. Now that my variables are complete, let us recall the general form of a quadratic function. Let us substitute the value of A, which is 1, in here, B, which is negative 3, in here, and negative 1 for C. Since we only have 1 for A, we do not write anymore the positive 1. So we have y is equal to x squared minus 3x minus 1. And if you're interested on the graph, here is the graph of this function. So here are the 3 points that we chose earlier. Let me show you another approach in solving this problem. Earlier, we used addition. What if I'm going to use subtraction? Let's do it. 3 minus negative 3 will give us 6. A minus A will be cancelled out. Negative B minus positive B will give us negative 2B. C minus C will also cancel out. So by using subtraction, I was able to eliminate two variables right away. That is a jackpot. So I can solve b here by dividing both sides by -2. So -2 and -2 will cancel out, and 6 divided by -2 is -3. So -3 is equal to b. This will be my equation 4. Let us choose again another two equations. Let me choose 1 and 3. Okay, since I have already eliminated b, I'm going to choose whether to eliminate a or c. Obviously, it is easier to eliminate c because their numerical coefficients are the same, which is 1. So I'm going to choose subtraction again. This will be 3 minus -1 is equal to 4. A minus 9a is -8a. Negative b minus positive 3b is -4b. And positive c minus positive c will cancel out. 4, -8, and -4 are all divisible by 4. So let us simplify. 4 divided by 4 is 1. -8a divided by 4 is -2a. -4b divided by 4 is -b. This will be my equation number 5. And since I have already the value of b from equation 4, I can substitute equation 4 to 5. Meaning, I'm going to substitute -3 in here. So negative negative will become positive. To solve for a, I'm going to move this 3 on the other side. It will become -3. 1 minus 3 is -2. And to solve for a, I'm going to divide both sides by -2. So -2 here will cancel out. -2 divided by -2 is equal to 1. This will be my equation 6. I already have the value of a and b, so only c is missing, meaning I can substitute 4 and 6 to either 1, 2, or 3. Since again 1 looks the simplest among the 3, I will substitute 4 and 6 to 1. So I will substitute -3 for b here and 1 for a here. Negative negative will become positive. 1 plus 3 is equal to 4. To solve for c, I'm going to move 4 on this side. It will become 3 minus 4. And this is equal to -1. Now my variables are complete. A, b, and c. And notice that these are the same values that we got earlier. So meaning we will also get the same quadratic function. I hope you understand our lesson with the two examples that I have discussed, plus this additional approach that I showed you. For the summary, again, here are the steps in creating an equation from a table of values. Our next lesson is determining the equation of a quadratic function when the given is graph.